Hi, everybody, and welcome to our Drinking Water Wise webinar series. Today, our topic is well maintenance and safety, and I'm your host, Natasha Matthew from Quinte Conservation. I also have with me today Trent, Jason, Haven, Marika, Tom, and they are all from different conservation authorities. We have the Trent Conservation Coalition, Cataraqui, Rideau Valley, and Niagara Peninsula Conservation. So they will be helping me moderate the chat, the Q&A function, and provide technical support today. And they have been a huge help with organizing this webinar series. So to start off our webinar, we'll start with a little bit of Zoom 101. We've used Teams, but we've moved platforms to Zoom. So we'll just go over a few housekeeping items. This webinar will be recorded and available on YouTube shortly after this presentation today. All participants, you should be muted and your camera should be turned off during this presentation. And if you'd like to participate or have a question, please use the Q&A function. It should be at the bottom of your screen. And if you are experiencing any technical issues, please contact Marika Livingston at marika.livingston@mrsourcewater.ca. I believe her email will be put in the chat. So now that we have gotten the Zoom info out of the way, let's begin with today's webinar. We are going to go over our short agenda. So we'll start off with an introduction to source water protection, what it is, why it's important. And then we'll go over well maintenance with our special guest, Kyle Smith. And then we'll pass it off for a presentation on well safety with our guest judge, Brittany Murcar. And then we'll follow it all up with some pre-submitted questions that registrants have asked. And then if there is time at the end, we will go over questions from the chat. So to start off, we'll talk a little bit about source water protection in Ontario. So Ontario has a multi-barrier approach to protecting municipal drinking water sources, all the way from the source to the tap in your kitchen or bathroom. This multi-barrier approach includes the Clean Water Act of 2006, which has several components to ensure that municipal drinking water is safe to consume. This includes locally developed source protection plan, risk management services, and many other implementation initiatives. Conservation authorities and several implementing bodies have actually worked together to develop and implement these source protection plans and policies all across the province. There are also resources for non-municipal systems, and we call those the best practices for source water protection. And these are basically initiatives that you can take to protect your source of rural drinking water. So these are for people who aren't on municipal drinking water systems. So basically, these best practices for source water protection, they are a voluntary guidance document that was developed by the Ministry of the Environment, Conservation and Parks. And they aim to protect Ontario residents who are not protected by the Clean Water Act or the source protection plans in Ontario. In this document, it provides a lot of information on how you can assess your system's vulnerability, any of the risks that are around, how to manage them, and it has various different options for different potential people to implement these strategies. This can be municipalities, residents, and other agencies or associations. So just to kind of give you a comparison between municipal and non-municipal systems, municipal systems, they have that multi-barrier approach we were talking about. So on the left-hand side of this diagram, we have the municipal systems where they have protections at the source of the water. They go through treatment. There's training for their water operators and testing, and it's safely distributed to your tap. On the other hand, we have private systems who they don't have access to all of those things. The owner of the drinking water system, so that whether that be a well or an intake, it is their responsibility to know how to treat their water, how to test it, and make sure that it's safe for consumption. So basically, the aim of the best practices is to help protect human health and the environment, extend your drinking water system's life, If you're well aware of how to protect your drinking water source, you can actually avoid the high cost of cleaning up contaminated water sources, seeking new sources if it's contaminated and you can't clean it, or even increasing treatment methods if you need to. It's also great to have these initiatives in place because it increases public awareness and accountability for drinking water stewardship. And it also helps in our land use planning decisions. So a couple of examples of some things that are in the best practices for source water protection. These are simple things that you can do at home. So if you are on a private system, you can test your drinking water regularly. These are actually public health drinking water test kits that are available. So you can test your drinking water very regularly. You can create an inventory of potential contamination activities. So if you're on your property and you're using a lot of road salt, that could be considered a potential contamination activity. So keeping a list of things that you do on your property. And then even going further to implementing a protection zone. So within 100 meters, let's say, if you have that much space on your property, you can make sure that certain activities aren't being done within that 100 meters to make sure you're protecting your source of water. Visually inspect your well or septic system annually. Make sure that there's no damage to it. Make sure if it's a septic system, does it need to be pumped out? Do you need to clean the effluent filter? Those kinds of things. Another thing is you can pump out your septic system every 3 to 5 years, depending on how big your system is and what type of system and so on. You can also use eco-friendly alternatives to commercial products. So using vinegar as a disinfectant or something like that. And just to continue on, we have a little bit more. You can always conserve water when possible. Certain areas in Ontario don't have a lot of water to tap into, so conserving water is always great. If you have hazardous material, make sure you're not dumping it down the drain. Make sure you're dropping it off at hazardous waste depots. If you do have fuel tanks, make sure they're stored in the double-lined tanks in case of a spill. And then if you are on waterfront property, you can also plant a shoreline buffer to help reduce runoff into those water bodies. So those are just some things that you can do as a landowner just to protect water and different sources of drinking water. And without further ado, we will pass it off. We have 2 guest presenters today. Our first one is Kyle Smith. He is the president of the Ontario Groundwater Association, and he's actually volunteered with the association since 2016. He is a graduate of Fleming College's Natural Resource Drilling and Blasting program and has been a licensed well technician in Ontario since 2009. He has contributed to groundwater investigations not only in Canada, but in the US, South America, and even Bermuda. Kyle is also a project manager and driller at Art of Arc Drilling Inc., where he's managed a multitude of different well constructions, rehabilitation, abandonment projects, and he's done that for over 15 years. So he has a lot of industry experience that exceeds the whole 20 years, and he's sharing his knowledge by teaching continuing education courses across Ontario so that other well technicians can meet current licensing requirements. So Kyle will take us through the well maintenance part of this presentation, and then we'll follow it up right after with Brittany Murcar. Brittany is a public health inspector with the Haliburton Kawartha Pine Ridge District Health Unit, and she graduated from the Conestoga College Bachelor's of Environmental Health program. Brittany has progressed in her career since 2019 with the Haliburton Kawartha Pine Ridge District Health Unit and has been focused on drinking water for the last 3 years under the mentorship of Bernie Mayer. So without further ado, I'd like to pass it off to our special guest, Kyle, to present the well maintenance portion.
Thanks, Natasha. I'm working here today with our general manager from the Ontario Groundwater Association, Trish Ludy. She prepares a lot of these presentations. So we'll let her go through the meat and potatoes, and then I can comment on any questions or any of the more in-depth things that we get into.
All right. Hello, everyone. So I'm going to be taking us through our wonderful presentation today, and I'll just start with a quick little history of the Ontario Groundwater Association. So in 1952, the province of Ontario mandated water well records and filling those out for all new wells. As a result, the water well drillers organized, and the first meeting was held in Tillsonburg in 1952. So we are going 73 years strong as the Ontario Groundwater Association. It first started off as the Ontario Water Well Association, and we later changed our name. But the Ontario Groundwater Association basically facilitates various sectors of the groundwater industry coming together for the delivery of safe and clean water supplies throughout the province. So throughout this presentation, we're going to cover a few different topics that are essential for well ownership and maintenance to ensure clean, safe drinking water. So we'll talk about some common types of wells in Ontario, the majority of them being drilled, dug, or bored wells. We'll talk a little bit about why well maintenance matters and the importance of regular well care. We'll touch base on well records and kind of understanding them as well as how to read them with some details there. And we'll talk about potential issues to note that will so that you can have better well maintenance, some best practices to keep your well in optimal condition, and then a few resources for everyone to be able to use. So what makes up a water well? A modern water well is more than just a hole in the ground. It's a carefully engineered system designed to access, protect, and deliver our clean drinking water. So groundwater collects in the spaces between the soil, sand, and rock. Wells access this water by penetrating into an aquifer, allowing water to naturally flow into the well and be pumped into the surface. Most Ontario wells rely on these confined or unconfined aquifers, depending on the geology of the area. So a couple of the key components of your well is the well casing. It's a pipe that lines the whole well to prevent collapse and block surface contaminants. Each well will have a well cap and a properly sealed cover at the top of the casing to keep out insects, vermin, debris, and surface water. There will be a pump. Usually, most commonly, the modern wells will have a submersible pump. It lifts water from the aquifer to your home. A well screen that filters out sediments while allowing water to enter the well. And of course, the aquifer, which is where the well is going to the underlying layer and getting that water bearing out of the rock or soil. And so now we'll talk a little bit about the common types of wells in Ontario. They vary in construction, depth, water source, and susceptibility to contamination, all of which influence their performance and maintenance needs. Some wells tap into the deep confined aquifers, offering reliable water year-round, while others rely on shallow groundwater, making them more vulnerable to seasonal changes and surface contaminants. Drilled wells are the most common and reliable well type in Ontario. They extend deep into the bedrock, which could be hundreds of feet, to access our groundwater. They use heavy machinery to drill a narrow diameter hole, about 4 to 6 inches, and they're lined with casing to prevent contamination, making them a durable and long-lasting option for homeowners. Dug wells are common in older properties. They're a little bit of an older style well. Dug wells are often dug by hand or by equipment and are shallow and wide, typically less than 30 feet deep. They collect water from near-surface groundwater sources, making them more susceptible to contamination from runoff, bacteria, and seasonal water table fluctuations. Bored wells are constructed using a boring machine. These wells are also shallow, but are reinforced with concrete tiles. They're typically found in areas where the water table is high but low yielding, requiring careful maintenance to ensure consistent water quality. A couple of less common types of wells are shore wells and sandpoint wells. Shore wells are constructed close to shorelines of lakes, rivers, or streams, typically accessing shallow groundwater near the water body. Often a shallow excavation or structure lined with stone, concrete, or timber. They usually provide a plentiful water supply due to proximity to surface water sources. They have a high vulnerability to contamination from surface runoff and fluctuating water levels, and they often require additional water treatment systems. Sandpoint wells, or otherwise known as driven wells, are constructed by driving a small diameter pipe fitted with a screened sand point directly into sandy or gravelly soil, and they're usually about less than 25 feet deep. They're pretty shallow. They can be installed quickly, often manually or with very simple equipment. They're inexpensive, fast to install, suitable for areas of shallow water tables, but they have a very limited water volume and vulnerability to contamination. They may also go dry during drought conditions. So what do our wells look like? This is a very common picture of a modern drilled well. It's got a nice sealed cap and a great well tag that everyone can view. And then just beside it is kind of the cross section of that drilled well for you to be able to understand the casing and the well screen and everything there, as well as the well tag at the top and a nice little mounded area to get any runoff away from the well. So just another cross section here, just showing you on a crazy slope, but basically, again, just mounding, preventing ponding around a well. So this is proper surface drainage for around a modern well. So here we've got a picture of a bored well. You can see kind of that concrete tiling or around the structure, and the cross section again, of course. And then we've got some pictures here of the inside of a hand dug well and a bored well here. And you can see how the hand dug well has a lot of contamination risk there to it. And here's just a couple of pictures of some not great conditioned wells that would obviously require some maintenance and some professionals to take a look at. So why well maintenance matters. The importance of well maintenance is to maintain proper well maintenance is essential for ensuring our safe and reliable water supply while protecting both your investment and the environment. Regular care and monitoring can help prevent contamination, extend the life of your well, and reduce costly repairs. So ensuring safe drinking water, regular inspections, and water testing will help detect contaminations from bacteria, nitrates, and other pollutants that you might not know about. Proper sealing and wellhead protection prevents surface water from infiltrating and preventing any potential health risks. And well maintenance helps maintain consistent water quality, reducing the risk of illness from unsafe drinking water. Well maintenance also prolongs the life of your well. It prevents buildup of materials, sediment, and bacteria that can clog your well screen and pumps. Identifies small issues such as declining water levels or pump inefficiencies before they become a bigger problem. And a well that is maintained properly can last decades longer, reducing the need for premature replacement, which goes really nicely into preventing costly repairs. Routine maintenance is far less expensive than emergency repairs on well or well replacement. Identifying any leaks, cracks, or declining performance early can save thousands of dollars in major repairs. And a neglected well can also lead to pump failure, pressure issues, or even contamination cleanup costs. And most importantly, well maintenance protects our groundwater resources and aquifers, preventing pollutants from seeping into groundwater, protecting local aquifers that supply our drinking water, and it reduces the risk of cross-contamination from abandoned or poorly maintained wells, which helps sustain a long-term water availability, ensuring wells function efficiently and do not overdraw our resources. So what can we do to inspect our wells? Check the well cap and casing annually. Check for any cracks, corrosion, loose fittings, or signs of any tampering. Make sure the well cap is secure and vermin-proof to prevent any insects, animals, or debris from entering your well. Look for any visible damage or signs of wear on the casing above ground. Test your water at least once a year. This will, normal tests from the public health unit are often for chloroform and E. coli, but there are more comprehensive tests that you can get done at other laboratories that we will talk about a little later. Using an accredited lab and keeping your results with your well records is really important as well. So keep hazardous materials away from your well. Do not store any fuel, pesticides, fertilizers, or any household chemicals near your well. Maintain a clear zone of at least 10 meters around the wellhead and avoid allowing pet waste as much as possible or compost piles near the well area. So we showed a little bit of a diagram of surface drainage, and so maintaining the ground around the well to slope away from the well. Avoid directing downspouts or drains towards the well, and make sure there's proper grading products, protects the well from surface runoff and contamination. So hiring a licensed contractor or licensed technician for any major repairs. We strongly suggest not to attempt any repairs or modifications to the well or the pump system on your own. Use a licensed well contractor registered with the Ministry of Environment, Conservation and Parks and members of the Ontario Groundwater Association. We have a lovely directory and a lovely interactive map that you can use. And ensure any upgrades or decommissioning meet provincial regulations. So what are well records? They're the official documents that provide detailed information about construction and performance of your well. These records are typically created by the licensed well driller at the time of installation. So we'll go through a little bit of what you can find on your well record, and then we'll show you a couple of examples, and Kyle will kind of take you through them. So what you'll find on them is the owner's name and address, the well location with details such as the lot, concession, township, municipal address, or any other kind of address details would be there, as well as geographical coordinates. They'll have a well identification, which will have your well tag number. It's typically affixed to the well casing. And it'll have the date of construction of the well as well. It'll have construction details such as the well type, whether it's drilled, dug, bored, or any other type. It'll have the total depth from the ground surface to the bottom of the well, as well as the diameter. The casing materials, diameter and depth of the casing installed to prevent the well walls from collapsing and to protect against contamination. Details about any screens that were installed, including the type, material, slot size, and interval depths, which are keeping out our sediment from the well. So it'll have some geological information, such as descriptions of the soil and rock layers encountered during the drilling, as well as the depths and thicknesses. It'll also tell you about any water-bearing zones and at what depths they were encountered. We'll also show you the static water level, so the natural level of water in the well before pumping, measured from the ground surface, as well as the water level during pumping, which will ultimately give you your well yield, the rate at which water can be pumped from your well. So we'll also have pump test data in there. It'll have the duration that the test took place, as well as the difference between the static water level and pumping water level, and your recovery rate time, which is the time it takes for the water level to return to static level. Water quality information would be included on it as well, including turbidity, color, odor, and any laboratory analysis that resulted in contaminants. It'll have your well contractor's name and license number, and it identifies the professional responsible for constructing your well under the Ontario regulations. Why do these well records matter? Well, they're not just paperwork, they're essential tools for protecting your water supply and your property. So you can use the Ontario Well Records map, or we also to help you kind of find any wells, and the Ontario members map from Ontario Groundwater Association can also help you find any licensed contractor that would be located on your well record. Check your property documents. Well records may be included in your home purchase paperwork or home inspection reports. You can contact the original well driller if you know who installed the well. They may still have a copy on file. Some contractors retain those records for several years, or you can request them directly from the MECP. So this is just a quick visual of how many wells there are in the Quinte area, and it's quite a lot, and these vary from private homeowner wells, cluster wells, and a number of test wells. So I'll pass it off to Kyle to talk about our well records in detail.
Thanks, Trish. That's excellent. So that last slide is of the interactive wells map that's on the ministry website. I really encourage people to get on that and play around. Every blue dot is interactive. You can click on it, and then most of the time it will bring up and generate the well record. So as we move forward, we'll show this this well record was developed in the early 2000s, and it's still the most widely used one by contractors in Ontario. So if you were to click on one of those blue dots, you could have this come up in PDF form, obviously filled out. And then you can learn things. If you weren't the one who constructed the well, you can learn on what the intended use was for that well. If it was an old historic well, maybe they had planned on using it for livestock, and now you've got a home on it and it's being used for domestic use. You may want to look into that because there are different construction regulations for uses on different types of wells. The method of construction is usually the type of equipment that does that work. The hole diameter in Ontario, we have a minimum of the top 20 feet has to be oversized. So our typical wells in Ontario are a finished diameter of 6 inches, but we want to see larger in that top 20 feet, and we'll have some examples as we go forward. And then down in the next little box blown up is the casing record. So in an overburden or a soil well, the casing extends right down to the aquifer and the water-bearing formation. In a bedrock well, the casing will extend into the bedrock, and then the rest of the well will be carried on without any casing and just an open rock hole, and that should be noted in that section. The casing construction with the screen, the last one, it's good to take note because screens take more maintenance than an open rock hole. So it can give you information there. And depending on your water quality, that would dictate on how frequently you would be giving maintenance to that well screen. And this section on the well record, the well yield testing, this is mandated that we must conduct a 1-hour pumping test on every well that is drilled other than test wells in Ontario. This is really good water information through here. So, we've got the top checkbox of is it clear and sand free? Others, you can have wells that produce murky water forever, and this is a spot where you would know that. And if you had water treatment in your house, you may not know the actual original quality of that water, if the treatment's working properly. If pumping is discontinued for any reason, it's typically because the well isn't making enough to sustain the pump tests. As we get down, you will see the disinfected checkbox. We really want to see that disinfected after the well construction phase. There are some reasons why there would be a no checkbox. Some of those would be an emergency well replacement. And then we see it a lot with farms when livestock can't go 24 or 48 hours without water, because that's your typical disinfection time. Then just above that is the well production. That's a very important one. And you can test that over time to ensure that it's staying the same. And if you do see a drop in your well production, if you're hiring a well technician to do pump tests every 3 to 5 years, that could be an indicator that you're getting bacteria or sediment that is slowing down the well production of your well. If all of a sudden you have a huge spike in production at your well, that would indicate to me that a seal or a casing has failed, and then your quality may be compromised. So that's the main well record that's used if you find those blue dots on the map. That's what it'll bring you to. And here's a good example. This one's actually from just up the street from me. You can see it says at the top, Jackson Homes. They will only show that information if it's a corporation that is the well owner. So this would have been a builder that was contracted to build the home, rather than a private or domestic owner. If say Trish were to construct a well, this would be blacked out on the ministry website for privacy reasons. And we get down into the location of the well. It's really interesting seeing the overburden and bedrock information to see what's actually under your feet and where your water is coming from. This is a nice well constructed down into a sandstone formation, which in our neighborhood is the Nepean Formation, which is known for excellent water quality. We jump off, these forms are split in half just so that they can be legible at size. But if we go over to the top right-hand side, we're looking at that pump yield test information, and you can see there's lots of good stuff there. The older ones, the hand-drawn, we see a little map. Some contractors do really well with hand-drawn maps. We really like the satellite images, and we're getting that more and more as the electronic well records have been released. Just to the left of the map is also good information where you've got our well contractor who constructed the well, all their licensing numbers, and also just above that is the water details. So you can see that as they were constructing the well, they found 3 different water-bearing zones. All were untested. Moving on to the next type of a well record, if you're clicking around that interactive map and one of these show up, this is a cluster well record. They're typically used in monitoring wells because you'll do multiple on a property. So this would be for monitoring an aquifer. This could be a government or a consulting or an engineering firm that is monitoring groundwater in the area. And they're kind of neat to see, and they usually come with a good site map too. So you can see they attach the map with the cluster well record, so you can get a really good idea of where those wells are. And then the newest version of the well record came out a few years ago. This is the electronic well record. As you can see, it's a fillable PDF, nice and clean. It takes away the handwriting and legibility issue with some of them, but it gives you unlimited fields as well. Most well contractors on the paper copies feel limited by the fields that are available, whereas this electronic copy, this electronic version allows you to expand all the fields to add as much information as you would or want to. This is also continued on the next slide. So these four cutouts are the electronic well record. It's much larger than the older versions, but again, that's so we can get more information on. We can see that there's nothing in the well yield testing portion, but if we go over to section 14, we can see that they attached the step testing somewhere else. So that's one failure on these, is when they are submitted to the ministry accepts all the attachments, but that's not presented to public. So in this case, the pump test info was submitted, but it's not reflected in the well record. And then again, at the bottom right, we've got all our well contractor information. And then this is just the bottom where you can put in satellite image to get the location of the well, which is a lot nicer. So those are the ones that you're mainly going to see, modern well records. But we've been putting these things in since the 20s, is as far as back as I've gone. So this is a well record from 1943. This well is still in use today, and you can see it's got the basic information. You've got your casing diameter, length. Rather than a breakdown of the pump test, we just have two lines that they pumped at 5 gallons a minute for 2 hours, and the pump was set at 73 feet. Again, hand-drawn maps might be a little bit more difficult to find, but through history, these well records are still on that ministry website. So those blue dots could hold anything. If you look on this one too, and the last one, the big black blob, that's what I spoke to before, keeping privacy in mind, unless you're a corporation or a government entity. This one here, this is from 1973. So this was the second newest version. You can see that it is similar to the more modern ones. They have been expanded a little bit, but through the 70s, we did see a change on well records slightly. So this is 1973. And the next one we go to is 1971. So you can see the bulk of the record is the same, but a few differences. If I want to go back, let's go back to the first one, Trish, the Jackson Holmes one. I didn't mention it before, but in the bottom left of the left-hand page of this, your annular space, the ceiling, I spoke about that top 20 feet of the well. That's a very critical zone. and we want to ensure that that is sealed. So this contractor here used cement and quick grout, which is a bentonite product. Bentonite is a dehydrated clay that's always looking for a water molecule. So if we had surface water getting into there, the bentonite would soak up that water molecule and hold it, and then almost become a like plasticine type substance that would repel water forever and ever. So that's you want to make sure that there's good information about your top 20 feet, which is your annular seal. So I guess we can go down through, and Trish, do you want to start chatting to us about some signs of if your well's having issues?
I certainly can.
Super, thank you.
So yeah, we're just going to talk about a few signs that your well might be in trouble, which could lead to serious issues, and we really want to make sure that we're protecting that groundwater for health. So sudden changes in taste, smell, and color, metallic sulfur or chemical-like taste or odors may indicate contamination. Discoloration, like rusty, cloudy color, could point to corrosion or sediment buildup, or even surface water infiltration into your well. And you always want to investigate these sudden or unexplained changes in the appearance of your water. Decrease in water pressure or flow. This may signal a failing pump or a clog in the system, or even just declining water levels in the aquifer itself. This could be caused by mineral buildup or damage to the piping, and gradual changes might go unnoticed. So you really want to track the performance of your well regularly and continue on maintenance regularly. So if you're pump cycling frequently or it's making noise, a pump that turns on and off rapidly could be due to pressure tank issues or leaks. Unusual sounds like grinding or humming may indicate your pump motor is having some problems. And ignoring these symptoms can lead to pump failure and very expensive repairs. Sediment or air bubbles in your water. A sandy, gritty, or cloudy kind of water may signal that there's problems with the well screen, the casing, or the aquifer. Air lines or air in your lines can point to a drop in water levels or a failing check valve. Sediment can damage the appliances and plumbing over time. So again, you want to make sure you're on top of the maintenance of your well. And if your water tests are showing contamination, presence of chloroform, bacteria, nitrates, or other pollutants means your well is compromised, and it might need some assistance with that. Contamination can come from surface runoff septic systems or failing well components, and you really want to seek professional help immediately and stop using the water for your protection as well. So if you notice any of these signs, it's really time to take action, and prompt attention can protect your health and long-term damage. So what do you do if you suspect a problem? You stop using the water if contamination is suspected. If the water looks or smells or tastes unusual, or you've received a positive well water test, stop drinking, cooking, or bathing with it until further testing is done. Please use bottled water or an alternative safe source until the issue is resolved. Continued use of contaminated water can lead to serious health risks. So a few resources for homeowners. Ontario has a range of trusted resources for you to help care for your well, access important records, and ensure your water safety. Working with a qualified professional is key to maintaining a safe, reliable, and regulation-compliant well system. Our website has a number of resources for homeowners, including fact sheets, videos on construction maintenance, as well as a few different programs for decommissioning your well if that's a requirement. We have a directory of licensed well contractors, both an actual physical book or like a PDF book, or you can use our interactive map. And our website can help you stay informed on best industry practices, as well as any kind of outreach events that we have. The MECP well records search tool, we showed you a little bit about that. I encourage everyone to go on and take a look and try and see if they can find their well records. And local public health units, they offer free and low-cost water testing for bacteria, which is usually just E. coli and chloroform. They also provide education like you're going to get today and can help interpret test results and guide your next steps. Licensed well contractors are trained, experienced, and operate under Ontario's Well Regulation 903. Their services can include routine inspections and preventative maintenance, disinfection and shock chlorination, pump and casing repairs, as well as well upgrades or proper decommissioning. All of our members follow industry best practices and ethical standards. Ontario Groundwater Association also supports a number of reputable labs that offer more in-depth water testing. Some of the testing includes nitrates, metals, and chemical contaminants. So we've got two here that are our members, TestMark and My Water Quality. Both very great to be able to use to find some more detailed information about your water. So whether you're maintaining, troubleshooting, or testing your well, choosing an OGWA affiliated professional helps ensure your water is safe, your system is legal, and your investment is protected. And that's all I've got for you guys.
Thank you so much, Trish and Kyle. That was extremely informative and very helpful. We are going to pass it off to Brittany, but please stay on so we can ask you some questions at the end. We do have some pre-submitted questions that we'd like for you guys to answer. But without further ado, we'll pass it off to Brittany.
Thank you. I'm just getting myself ready to share here. You can see that?
Yes, looks great.
Excellent. So thank you for the introduction. My name is Brittany Murcar. I'm one of the public health inspectors here at Legacy HKPR. So I'm going to be presenting to you today on some well safety tips and testing your drinking water. So first off, this is just a map of all the Public Health Ontario labs and public health unit offices across Ontario. If you're unsure what health unit location you fall in, you can actually look up the Public Health Services map, plug in your address, and it will come up with any contact information that you may need. So why is testing your drinking water important? So ultimately, we want to prevent illness. We want to protect the most vulnerable populations who are at greater risk and experience greater health effects from certain contaminants. So these are infants, children, elderly, immunocompromised, and those of reproductive age. So public health units offer pickup and drop-off services to facilitate free well water testing services offered through Public Health Ontario labs. The samples are tested for indicator bacteria. The first one being total coliforms. So you can find these in sewage, animal waste, vegetation, and soil, and they indicate the presence of surface water in your well. So total coliforms are not likely to cause illness. However, their presence could indicate your drinking water could be contaminated by more harmful microorganisms. Next is E. coli. So E. coli is found in the intestinal tract of animals and humans and indicates fecal contamination of your well by a nearby source. Most strains of E. coli are harmless. However, their presence can indicate there are other harmful bacteria, viruses, or parasites in the drinking water. So understanding your results. So these are some common results that we get people calling into the public health unit for. So 0 E. coli and 0 total coliform, that is satisfactory. That's what we want to see. That's considered safe to drink. What I will mention though is PHO labs only sample for indicator bacteria. A satisfactory bacterial sample does not mean the water is free of chemicals, heavy metals, or radiological contaminants. So 1 to 5 total coliforms, we would always recommend you resample. This is to rule out sampling error, and we want you to continue to sample once a week for 3 weeks to get an idea of your water quality. What I want to mention though is if you're consistently getting hits of bacteria counts in your well water, it's worth noting that resampling won't fix the issue, and there's an underlying issue that needs to be addressed. This can be done through well shocking, treatment installation, or contacting a well professional may be necessary. As you can see on here, one or more E. coli and then more than 5 total coliform are considered unsafe to drink. And I'll go through some corrective actions in the next couple of slides. On the right-hand side here, you'll see a couple other results that we do get people to call in about at the health unit. So no data overgrown with target means that the indicator bacteria are present in the sample, but the bacteria, there's so much in the sample itself that they actually can't provide you a numerical value. This would also be considered unsafe to drink. No data overgrown with non-target. It's got a bunch of other bacteria that are found in the environment. Again, they can't give you a numerical value, and the amount of bacteria might actually interfere with being able to say whether indicator bacteria are present. Last one, unable to test. So it can be a sample result if the water submitted has a strong odor, discoloration, or debris that can damage the equipment. You may also see this result if your sample is submitted too late to the lab. So what do you do when your water is contaminated with bacteria? You can boil your water for a minimum of 1 minute, or you can use bottled water until we can get to the actual core of the issue. So when you get a bad sample, you want to discard of any food or beverages that have been made with the contaminated water. You want to use boiled or bottled water for drinking, brushing your teeth, washing fruits and vegetables, making ice, juices, puddings, and for baby food or formulas. So dishwashing, you can wash your dishes with hot and soapy water and rinse them as normal. However, you want to add a sanitizing steps. So the normal household kitchen sink is approximately 2.2 gallons. So you want to fill your sink just below the halfway mark, and then add a 1/4 cup of non-scented bleach. You want to mix that together, and then each dish should be submerged in the solution for 45 seconds to ensure any remaining bacteria on the dishes themselves is killed. For bathing and washing purposes, adults, teens, and older children can shower like normal. We just want to avoid getting it into our mouth. And then smaller children, we want to give them sponge baths so that we have a bit more control of where the water is getting on their body. So if you're experiencing any type of stomach cramps, nausea, or diarrhea after consuming bacteriological contaminated water, we want you to contact your health care provider and discuss that with them. So how often should you test your well water? We recommend a minimum of 2 to 3 times a year, typically in spring and fall. However, sampling should be considered after heavy rainfalls or floods, after long dry spells or drought, after the well hasn't been used for a long time. So if you haven't used your well water for a long period of time, you should flush your system thoroughly to remove any stagnant water in your lines prior to sampling. You can do this generally by running your taps for about 10 minutes to ensure you're getting fresh water directly from your well into the property and you're sampling that. Additionally, we recommend sampling if there's any change in land use or activities near your well. You notice any change in color, taste, or smell of your well water, any repairs or maintenance are completed on your well, and then any construction activities, so excavation or even a septic system installation. So I do have a brief video that goes over how to take a water sample correctly. I do want to make sure, I'm going to play this for you shortly. I really hope that the sound works. Okay. So that was a brief overview on how to take your water sample correctly. I have written down the instructions again here. I do want to stress a couple of key points. So we always want you to take your water sample from the kitchen tap. That's an accurate depiction of where you're actually using the water. So we want to know that that water is safe. Again, removing the screens or attachments for the tap. I understand that newer taps these days you might not be able to actually get that off. So you can mix a 1 part bleach, 10 parts water solution in a cup, and then dip the whole end of the attachment or the tap directly in that cup for about 45 seconds. That will actually allow the inside of whatever that fixture is to be disinfected. Again, run the cold tap for about 3 to 5 minutes. Remove the cap from the sample bowl, as mentioned in the video. We don't want you to touch the inside of the cap or set it down. That can actually introduce bacteria to your sample and then change the results ever again. Fill the bottle up, replace the cap, and you want to keep it cold until you submit it to the public health unit. Increased temperatures do allow bacteria to grow in a sample. We want to give you the most accurate sample results that we can. And then the sample needs to be submitted within 24 hours to the health unit to allow enough time for the lab to do the samples and get you your results. So next we're going to move into well shocking. So when should you shock your well? So a new well is installed or well maintenance or a pump service is done. Generally, any good contractor will do this for you, depending on the well use based on the presentation Kyle just gave. So bacterial contamination. So it is worth noting that shocking your well is not a long-term solution. So if you're consistently getting hits of bacteria, you should seek professional help and have treatment installed. So shocking your well is a multi-step process that, if done incorrectly, can have negative impacts on the environment, your well casing, and your well pump. So in the next few slides, I will briefly be going over the steps of shocking your well. However, if you do not feel comfortable completing this process yourself, we always recommend contacting a professional. So this is an overview of the tool that we as public health inspectors use to calculate the amount of bleach that you need to effectively shock your well. Most of this information can be located on your well record if you have one. So as Kyle mentioned in his presentation, the average well diameter for a drilled well is about 6 inches. The well depth you'll get from your well record. I've just plugged a couple numbers in here to see to show you what it looks like overall. Desired concentration of chlorine, we want it to be at 100 ppm. That's considered a sanitizer, which will effectively disinfect the inside of your plumbing. And then concentration of your disinfectant. So I've got 8.25% in here. That's usually what household bleach sits at. However, if you're going to do this yourself, you're going to check the concentration of the disinfectant on the side of the bottle yourself to make sure that the numbers that are being calculated are accurate. So steps for shocking. This is a brief overview. So you want to store enough water to meet your household needs throughout this process. Generally takes 12 to 24 hours. So you can either store bottled water or boiled water during this time. Generally, as public health inspectors, we recommend doing this overnight to avoid any water use disruptions in your home. You want to estimate the chlorine necessary to disinfect your drinking water. So you can either do it yourself using that lovely tool, which I believe is going to be provided to you in this session. Contact a professional or even your local public health unit. A health inspector is always on hand to be able to help you do that calculation. So whatever that amount of chlorine is, you're going to mix that chlorine into 5 gallons of water. We want to dilute it a little bit before we actually pour it down the well head. When you pour it down, you can take your well cap off, pour it directly in. You want that chlorine to thoroughly mix in the well. So you can either do this by dumping another 5 gallons of water down, or actually using your garden hose and putting it down the well head and putting some water in there, just so that chlorine has the opportunity to mix with the water in your well. Once it's all mixed thoroughly through, you want to open all your taps inside and allow the water to run in your home until you can smell that chlorine coming through your faucets. If you can't smell the chlorine after a while, you might need to continue flushing for longer. Mix the chlorine in a bit better using more water down the wellhead. And last resort is we want you to add more chlorine. So once the chlorine's in there and you can smell it through your taps, you want to let the chlorinated water stand in the system for about 12 to 24 hours. During this time, we don't want you to use or consume the water itself. Once it's stood in the system for that period of time, you want to run the chlorinated water out of the system through either a garden hose. We generally recommend people on septic systems don't run out the chlorinated water into the septic itself, as it can destroy some of the good bacteria that actually decomposes some of the bits and bobs that are in there. Once the chlorine has been run out, we want you to wait 48 hours and then submit a sample to the health unit using the proper sampling technique we just went through. So if the above steps don't alleviate the problem, it's recommended that the source of the ongoing contamination be determined and corrected. And you can do this by contacting a professional. So if you're concerned that your well may be contaminated by chemicals, heavy metals, or radiological contaminants, you can use licensed MECP laboratories to conduct testing. These labs are used to complete testing for all small drinking water systems in Ontario under Regulation 319 and offer an at-cost service to their users. Now I'm going to go through just some common contaminant sources and associated health concerns. So arsenic, it is odorless and tasteless. It's naturally occurring and can be as a result of mining or industrial activities. It's associated with increased risk of skin cancer and can cause skin, vascular, and neurological effects. The MAC, or maximum acceptable concentration, is 0.01 milligrams per litre as per the Ontario Drinking Water Quality Standards. Next one is copper, again, naturally occurring or can be attributed to the use of copper pipes and fixtures in your home, as well as agriculture or mining activities. The guidelines for Canadian drinking water quality recommend that the maximum acceptable concentration for copper is 2 milligrams per litre. Although copper is essential for humans, In high doses, it can cause intestinal upset and can impact the function of liver and kidneys. Some indications that you may have high concentrations of copper in your water is a metallic or bitter taste, blue or greenish stains or scaling on some of your fixtures. But the only way to truly confirm its presence and the amount is to actually test for it. Lead, so over the last few decades, lead in the environment has significantly decreased and is not usually found in natural water sources. However, it can be found in plumbing components made with lead or galvanized steel pipes. So lead in plumbing components can be found in older homes and in fixtures purchased from countries with less stringent manufacturing requirements. The Ontario Drinking Water Quality Standards have an MAC for lead of 0.01, and the guidelines for Canadian drinking water quality have the MAC for lead as 0.005 or as low as reasonably achievable due to the significant health effects associated with having lead in your water. So lead is a carcinogen and is proven to have effects on children, reducing intelligence, causing behavioral issues, and causing renal dysfunction and high blood pressure in adults. Manganese at high concentrations can cause a metallic taste and leave black stains in toilets, tubs, and on your laundry. So the Canadian guidelines for manganese is 0.12 milligrams per liter. Manganese is naturally occurring in some areas and can also be a result of mining, industrial, and landfill activities. It can cause issues with neurological development, deficits in memory and motor skills, and formula-fed babies may be at higher risk. So nitrates and nitrites, also odorless and tasteless. They're associated with agricultural industry, but can be naturally occurring in some areas. The MAC for nitrates is 10 milligrams per liter and 1 milligram per liter for nitrites. Both cause blue baby syndrome, so often occurring in children under 6 months old, affecting the child's ability to absorb oxygen, causing a bluish discoloration to the skin, lips, and nail beds. Nitrates and nitrites can have effects on thyroid glands, and even short exposures can cause illness. Uranium. Odorless and tasteless, again, naturally occurring in some areas and is associated with nuclear, mining, and industrial activities. The MAC of uranium in drinking water is 0.02 milligrams per liter, as per the Ontario Drinking Water Quality Standards. Increased levels have been known to cause damage to bones and kidneys. So should you receive a water sample result that is over the maximum acceptable concentration, we would highly recommend you consult your doctor. So I would like to mention that MECP labs offer broad spectrum testing. You may also wish to contact a local professional who has local insight into what contaminants may be considered common in your area. So boiling your water that is contaminated with chemicals or heavy metals is not recommended, as it can concentrate the contaminant. So we want you to stop drinking your water, find an alternative drinking water source, whether it be bottled or municipal at the time, if that's available. We want you to contact a professional who can help you to find, eliminate, and or treat the source. So there were several questions submitted prior to the presentation regarding sulfur. So where does that rotten egg smell come from? So it can come from it's naturally occurring from decay of organics and erosion of rocks, or it can be from sulfur-reducing bacteria, which can be found in your well, in your water tank, or even through your plumbing in your home. So there's different ways to treat it depending on where it's coming from. So aeration of your well, it can like adding oxygen, essentially. Water softening can remove small amounts of sulfur coming into your well or into the distribution in your home. Filtration, green sand or carbon filters, continuous chlorine drip can actually help reduce some of the bacteria. And then for hot water tanks specifically, increasing the temperature to about 60 degrees Celsius, or actually replacing the magnesium anode to a zinc aluminum anode can also reduce that rotten egg smell as well. So I'm briefly going to go over some types of water treatment. So for disinfection, ultraviolet lights tend to be the go-to for residential treatment, depending on your source water quality. Most, if not all, systems require 5-micron pre-filtration. As long as manufacturer instructions for maintenance and installation are followed, they are dependable and effective systems. Chlorine and hydrogen peroxide, they're relatively low cost, low maintenance. Regular checks of chemicals would be required. Ozone can be very expensive and dangerous if not maintained without proper training. So filtration, depending on what you're trying to get rid of. So if you're looking to get rid of iron in your drinking water, there are specific iron filters to remove that. Activated carbon filtration generally focuses on aesthetic objectives, so odor or unpleasant taste. An example of a activated carbon filter would be like a Brita filter that you would use at home. Microfiltration, depending on the pore size, can get rid of sand, silt, sediments, and very, very small pore sizes like 1 micron absolutes can actually get rid of some bacteria and parasites. Water softening removes minerals and prevents scaling in your plumbing fixtures. And previous to this presentation, there was quite a few questions regarding removal of heavy metals, pesticides, and other contaminants. Some reverse osmosis systems can do this. So they are multi-stage water purification systems. They can be expensive in comparison to other treatment options on the market. Generally, homeowners have these specifically for a drinking water tap in their kitchen. However, full home systems are available. RO systems do have the capabilities to remove some contaminants of concern, such as heavy metals and pesticides. However, it's all dependent on the media quality, and we would always recommend contacting a water conditioning professional to find out what the best and right option is for you. So when in doubt, call your local public health unit. As a public health inspector, we are here every day to essentially educate you on any issues that you need to do with well water. You can give us a call anytime. We always recommend calling your specific health unit to do that. Here are some resources that I used today to put together the presentation. Thank you for having me, and we will be taking some questions at the end.
Awesome. Thank you so much, Brittany. That was very informative. I'm just going to share my screen here so we can go through the pre-submitted questions. There we go. So we'll start off with how do we know a well was properly constructed? This one might be a good one for Kyle.
Yeah, the first thing is, like we discussed earlier, try to dig up that well record. If you can't find it on the ministry site, there may be some municipal options. Maybe it wasn't constructed with a well record. There are tools that well contractors in Ontario have that we can build a well record. We can find those casing depths very unintrusively. So if you can't find that record, then contact your local well contractor.
Awesome. I actually didn't know that you guys could make new well records. It's quite cool. Our second one is how often should the well itself and the pump be checked? I know we said annually, but if there's anything different for the pump, maybe?
With pumping systems, I usually go with about 3 to 5 years. And the biggest thing is your water quality. If you have high manganese or high iron, you could be plugging your pumps up and running them prematurely, or really mineralized water can actually rot out your casing quicker than usual. But yes, testing the water in the well as much as you can. But the well itself, I would say 3 to 5 years, or if you notice any change in your water quality or volume.
Thank you. And then another one was, are water pressure changes indicative of anything?
Yeah, 90%, probably 99% of the time, if you're noticing abnormal pressure changes, it's likely a bladder in a pressure tank. Um, Often that's the case. Sometimes it can be electrical related if you've got some grounds or something for your electrical distribution to the pump. But typically it's a pressure tank bladder. And then down the line, number two would be your pressure switch. Then they do tire out.
Would you recommend calling a plumber for that? Or
There
well,
are lots of plumbers with licensed well technicians for sure. The reason I would say find a well technician, and whether they're a plumber or pump installer or driller, is because they understand the system. And if it's a consistent drop in pressure, it may be a ruptured line as well. And that way, a lot of well technicians who are drillers would rather have a plumber repair that so that they can keep drilling.
sounds good. Thank you for the clarification on that one. Is there a way to know the water level in my well? I think you kind of went over this one a little bit in your presentation on well records, but maybe at a given time they wanted to check.
Yeah, for homeowners, it's good to do. We can check our well record. The static water level will be on that well record, so you have a reference point to go from. Well technicians are the best to do this just because removing your cap can introduce contamination into your well. So if you're doing this yourself, be very, very cautious. And you can look up on YouTube, tie a rock to a string. Don't do that. If you're a homeowner doing it, what we will encourage is use a range finder, a laser range finder or a depth finder. It'll bounce off that static water level, and that way you're not introducing anything into your well. Just the riskiest thing would be removing the cap and replacing it properly.
That's very cool. I didn't know you could do that either. Um, there is a lot of blasting going on in a new development nearby. What do we need to be aware of that could result from the blasting?
Yeah, so I assume it's maybe a subdivision development. It doesn't sound like this is long-term like quarrying or something. The first thing when you have really destructive construction like that is you want to keep an eye on turbidity. So turbidity is kind of a buildup of sediment, non-harmful sometimes in your water. If you notice that change, then contact someone right away, whether it's the town, the public health unit, as well, because once they blast and stuff, and they'll likely introduce a dewatering system, which can change the course of groundwater and pull contaminants from other ways that's not natural. A lot of times with these, the municipalities or a consulting engineer will approach local well users and ask if they will be a part of the monitoring through construction. Typically, that's installing a data logger in your well. They don't keep so much of an eye on quality because the other things are earlier indicators in your yield and your water level. I hope that answers the question.
Yeah, I think it does. Thanks, Kyle. And what is the life cycle of a well pump and approximately the cost to replace one? Is an inline sediment filter recommended?
I say any filtration is welcome for sure. A UV light and a sediment filter, that's kind of the go-to in the industry now. They come in nice packages with a countdown so that you know when to expect to change your light or your filter media. Definitely recommended in all groundwater applications. The life cycle of a well itself is 70 years. That's just what our manufacturers tell us the casing degrades at in optimal condition. Like I said before, mineralized water could reduce that dramatically. And then the pumps, they range so much. We have pumps in certain situations where we're replacing them every 3 years. And then we've pulled some pumps out from the early 70s that are still doing their job today. There are ways for well technicians to test it unintrusively by checking the ohms and the resistance within the pump. So if we know what that pump is, there's an original spec on the resistance within that pump, and we can check from the wellhead without pulling that to see if that has lowered over time, which will give you an idea of the deteriorating life in your pump.
Awesome. And do you know an approximate cost for a change of a well pump?
The pumps themselves, they're for a good well pump, high quality with modern technology in it, you're around $2,500 for the pump itself. The biggest thing is your depth. So if you're over 100 feet, you'll probably need a contractor to come in that will have a hoist or a pump truck or a crane to remove that submersible pump from your well. If it's shallower than 100 feet, it could be much cheaper. And we're talking about your typical 6-inch domestic well. Anything that would be an 8-inch well would have a larger than a 1-inch distribution pipe. And typically you would definitely need a crane or some sort of equipment to remove that.
So thank you so much, Kyle. This one might be a good one for Brittany. How can pesticides be removed from water?
So as I mentioned, probably reverse osmosis, like multi-stage filtration, nanofiltration, that kind of thing, have the potential to move it. It depends what exact fertilizer we're talking about and how big the particulate is itself. Again, recommended to contact a professional like water conditioning company, and they can provide some better recommendations on what you're working on, what you need to use.
Awesome. Thank you for that guidance. This one could be for either Kyle or Brittany. How effective is a UV system?
Why don't you go ahead, Brittany?
Yeah, I think I covered this a little bit in the last part of my presentation there. So realistically, they seem to be used quite frequently in residential and large scale commercial kind of water operations. They are very effective as long as you have the appropriate filtration prior to the UV to actually deal with the water quality coming into the building. So as I mentioned in my presentation there, most UVs require a minimum of 5 micron prior to getting to the UV light. I think that should be kind of enough information. Obviously, you want to get a UV light that is, I guess, equipped to deal with whatever water usage you're dealing with, so high or low capacity in that manner.
Awesome. Thank you. We have a lot of iron in our water, and is there anything we can do at the well level that can be done? Brittany, did you want to try that one?
At the well level, that might be Kyle's.
Oh, that might be Kyle.
Yeah.
Yeah.
Yeah, well, Brittany did mention it before, is constant chlorine injection into your well. Have a professional water treatment specialist can size that up for some situations. That's a really good one that Brittany mentioned. Another one I'm familiar with is a at the well. It's called an air well system, and essentially it's an air injection into your well that removes that. And I think Brittany mentioned it for sulfur. It works really well also to get that at the well even before it's transmissed into the house.
So, and that concludes the questions from our pre-submitted questions. So I'm going to turn it over to my lovely counterpart, Trent, to go over the questions that were discussed in the Q&A function.
Hi, everyone. Thank you, Kyle, Trish, and Brittany for their wonderful presentations, and for our guests for submitting a number of questions. I think we've tried to answer a few of them just through the text filter feature, but there's a couple I'll propose to our guests here. First one, probably for Kyle. I think I know what you're going to answer, but they're looking at getting their below grade well components inspected. Are there any regulations regarding how frequently these should be inspected? And is this something that they could do in-house if they believe they have the equipment or capabilities, or should that be left to a licensed well technician?
Yeah, I'm just reading through this question right now. Low grade components inspected. So we're pulling the pump. That's typically if they're corrected, if they're built properly, that's all you're really inspecting is the casing and the pump rather than digging up things like your pitless adapter and distribution lines. Kind of sounds like that's more of a municipal situation. If you are dealing with a system where you're distributing water to anyone other than yourself, then there is definitely a set of regulations that you have to follow. I don't know if Brittany could comment on those small distribution systems. But definitely if you've got, I think there was mention of several wells there, that leads me to believe that, yeah, it's a commercial type system and you would definitely want to get a well contractor in for that.
All right. We also had a couple questions about if the well not showing up on the interactive map for the records, or if it is, there's no data included with the records. What does that mean? You have any advice around that?
Yeah, well, we play with that map often for our business and we run into it a lot. Throughout the decades, there are lots of unlicensed well contractors that just wouldn't submit well records. So that's not to say that the well wasn't constructed properly. You know, through the 40s and the 70s, there were lots of contractors or farmers and homeowners doing their own wells and just working in the shadows, not knowing that there was a registration or an industry that records this stuff. Modernly, a lot more people are submitting these well records. So it would indicate not that 100% your well was constructed improperly, but it was likely done by an unlicensed person.
Right, makes sense.
Oh,
A little
sorry,
bit of
Jen.
a
And the missing information. I spoke about legibility, and a lot of the older ones, if they couldn't read it, they just don't fill in the fields.
got it. Someone was asking about implementing kind of unique standards for wells. So as part of a plan of subdivision. So beyond the OREG standards, like extended casings or extra setbacks. Is that something they can just note in the subdivision agreement? It sounds like they're worried that might not get to the well driller themselves.
Yeah, this is a sticky one because, you know, the city of Ottawa requires grout inspections. Some other municipalities do have those requirements of deeper casings, larger setbacks. It's really on the contractor to find and know and learn this information. The Ontario Groundwater Association does its best to get the word out for those conditions in certain municipalities. The only kind of policing of it that I see is on new home builds. So if these recommendations or higher standards are implemented by municipalities, the only kind of enforcement they have is after the work is done at a new home. they can request that well record and maybe a certificate of compliance, maybe an engineer's stamp before they give an occupancy permit for that home. That's where I kind of see the policing in it. Other than that, it's just getting the word out to the contractors in those municipalities. Hope that answers it.
Yep, I think that's pretty good. Maybe a question for Brittany now. What if the water goes through the water softening system before the tap in the kitchen? Does that matter for water testing?
So essentially, when we're doing water samples, we're doing it at the consumer level, right? So if you have any type of treatment in your home, you want to be sampling post-treatment to get an accurate representation of the water that you're actually using inside your house. So it shouldn't matter, won't make any difference, and we want you to sample at your kitchen tap, post-treatment, whatever you've got on that system.
Yep, got it. Makes sense. Thanks, Brittany. We had a question about setbacks from well to septic system. Looks like it was answered. I think it's generally it is at least 15 meters or 50 feet. Question.
We are running low on time, so maybe please
Yes.
one more question and then we'll
Someone asks, are well water test results publicly available, or are they private records?
I don't believe so. If we're talking about private residences, generally they're not publicly available.
Got it. Yeah, I think that should pretty well cover everything. Maybe one more for Brittany here. Do you have any advice for a well that repeatedly displays bacteria exceedances, even though multiple chlorine shocking has occurred?
Yeah, so kind of as I mentioned in my presentation, like shocking is it's not a long-term fix. If you're consistently getting bacteriological results like TC and E. coli, you want to install some type of treatment. It might be that your well is failing. It depends on what type of well you have and how secure your well is. But if you're consistently getting bad results, you need to look at some form of treatment on that system.
Got it. That makes sense, certainly. All right, I think I'll pass it back to Natasha to wrap things up here.
Yeah,
Thank you, everyone.
for the people who are still online, we're gonna launch some polls just to get some feedback from you so we can keep making these webinars better for the next time. So Marika, if you could launch those polls, and then we'll have the participants maybe do a minute, and we'll let you guys fill out those polls for us, and then we will be done with the webinar today. We do appreciate everyone's feedback. It does help us with making webinars better in the future and taking into consideration what you liked. Alrighty, as you guys finish up those polls, I just wanted to say thank you to everybody, our special guests, Trish, Kyle, and Brittany. You guys did an amazing job, super informative presentation. We do have another webinar coming up. It is available to register starting right now. It is going to be on the history of source water protection. And it'll be on it'll be on May 21st at 1:30 p.m. and you'll hear from Venik Ramin from the Walkerton Clean Water Center. So again, thank you everybody for participating. We hope you have a lovely rest of your day, and keep being water wise.